Hello everyone, welcome to our Chemistry EL Phase 2 presentation. Today me and my group members from RV College of Engineering of IAC department are here to give a presentation on the topic Applications of Carbon Nanotube Polymer, Composites in Solar Cells. So let me introduce my group members. Our team consists of myself Ankush, Karthike, Mohit and Shantanu. So now let us begin with the introduction part. So before knowing what is the need of CNTs in solar cell, we must know what are solar cells and CNTs. A solar cell or a photovoltaic cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect, which is a physical and a chemical phenomenon. It is a form of photoelectric cell defined as a device whose electrical characteristics such as current, voltage or resistance vary when exposed to light. Individual solar cell devices can be combined to form modules, otherwise known as solar panels. The common single junction silicon solar cell can produce a maximum open circuit voltage of approximately 0.5 to 0.6 volts. Solar cells are described as being photovoltaic, irrespective of whether the source is a sunlight or it is an artificial light. In addition to producing energy, they can be used as a photodetector. For example, an infrared detector, detecting light or other electromagnetic radiations near the visible range or measuring light intensity. The operation of a photovoltaic cell requires three basic attributes. The first one is the absorption of light generating either electron-hole pairs. The next one is the separation of charge carriers of opposite types. And the last one is the separate extraction of those carriers to an external circuit. In contrast, a solar thermal collector supplies heat by absorbing sunlight for the purpose of either direct heating or indirect electrical power generation from heat. Now moving to the carbon nanotubes. A carbon nanotube is one of the most important nanomaterials. Before 1991, only two main allotropes of carbon were known. In 1991, a Japanese physicist, Sumio Lizima, invented CNT, which is another allotrope of carbon nowadays. Nanotubes are formed by folding or rolling two-dimensional graphite into a cylindrical shaped structure. Nanotubes are hollow from inside. The diameter of the nanotube is around 1 to 3 nanometers. The length of the carbon nanotube is much higher than its diameter. Nanotube length generally goes to a few micrometers. In short, we can say that carbon nanotube is a folded form of the two-dimensional graphene sheet. Carbon nanotubes are stiff. They are as stiff as diamond, which is the hardest natural material in nature. They can be single-walled or multi-walled with a diameter of less than 1 nanometer, consisting of several concentric interconnected nanotubes with a diameter of more than 100 nanometers and a length of few microns, even millimeters. Like the building blocks of graphene, carbon nanotubes are chemically sp2 bonded, which is a form of extremely strong molecular interaction. This characteristic is combined with carbon nanotubes. The nature trend of van der Waals forces together makes it possible to develop high strength and lightweight materials with high conductivity, which makes them very attractive for various applications. Now moving to the types of carbon nanotubes. As the name suggests, single-walled carbon nanotubes are composed of a single layer of cylindrical graphite. Single-walled carbon nanotubes are very important because they have certain properties that other nanotubes do not have, and these properties create interesting applications in various industries. The central part of the tube is formed by carbon nanotube atom, which is sp2 hybridized, and the end is formed by the specially distributed pentagonal and hexagonal rings so that the tube has the correct curvature and allows the graphite cylinder to be closed. Single-walled carbon nanotubes have a diameter of 0.7 to 10 nanometers. It is usually less than 2 nanometers. Now moving to the multi-walled carbon nanotubes. Multi-walled carbon nanotubes are a special form of carbon nanotubes in which multiple single-walled carbon nanotubes are nested within each other. Multiple carbon nanotubes are elongated cylindrical nano objects made of sp2 carbon. They are 3 to 30 nanometer in diameter and can grow up to several inches long. So their aspect ratio can be between 1 lakh and 10 million. They can be distinguished from single-walled carbon nanotubes based on the structure and stiffness of multi-layer carbon nanofibers. Based on different wall structures, smaller outer diameters and hollow inner parts. Now let us see some of the other key points. So one of the most promising applications of carbon nanotubes will be the next generation of solar cells. Carbon nanotubes can be used in photovoltaic devices for light harvesting and dye sensitized solar cells. Now moving to the next point, organic photovoltaic devices. So before knowing what are organic photovoltaic devices, we must know what are organic solar cells. So an organic solar cell or a plastic solar cell is a type of a photovoltaic that uses organic electronics that deals with conductive organic polymers or small organic molecules for light absorption and charge transport to produce electricity from sunlight by the photovoltaic effect. Now organic photovoltaic devices are made up of thin layers of organic semiconductors such as polymers and low molecular weight compounds, usually around 100 nanometers. Carbon nanotubes have some very unique characteristics that make them very useful for many different applications. Traditional single junction silicon solar cell can generate a maximum open circuit voltage of 0.5 to 0.6 volts. Now let us check what is the need of CNTs in solar cells. Because of the need to produce green energy sources, there is a great interest in solutions to improve solar cell efficiency. The cells that are most commonly used commercially today are silicon-based solar cells. Stability of high purity silicon, excellent charge carrier properties, and sophisticated processing technologies have resulted in silicon dominating the photovoltaic market. However, the manufacturing process of the high efficiency silicon solar cells suffer from poor performance, and therefore these solar cells are expensive, prevent of silicon from making a significant contribution as an energy source in the world. To solve some of these problems, thin film solar cells such as cadmium telluride and copper zinc tin sulfide and some other silicon thin films have been the subject of intense research. The heavy metal cadmium is toxic and the metal is expensive, which limits the development of cadmium telluride and copper indium gallium selenide solar cells. The expensive material was recently introduced and is found to be not useful in commercial life. Organic materials have both conductive and semiconducting properties that are really promising for optoelectronic devices. For solar cells, organic materials are attractive because of their potentially low cost, ease of manufacture and high throughput, suggesting that organic materials have the potential to have a major impact on the photovoltaic market, which allows light to be absorbed into a very thin layer, resulting in low cost solar cells. In addition, the efficiency of organic solar cells increases with the temperature, while most of the conventional inorganic solar cells lose efficiency with increasing temperature. Materials, which include organic molecules, conjugated polymers, and four typical carbon materials, such as amorphous carbon or fluorescence, CNTs, and graphenes, they are used for organic and inorganic hybrid solar cells. Materials for organic and hybrid solar cells. Research of single-wall carbon nanotube-polymer solar cells was conducted to develop alternative, lightweight, flexible devices for aerospace applications. Solar cells have undergone considerable development over the past 2 decades. Now moving to the properties of carbon nanotubes. So basically they are considered into they are divided into two major categories: electrical properties and thermal properties. So depending on their chirality and diameter, CNTs can be either metallic or semiconducted in their electrical behavior. Theoretically, metallic nanotubes can carry an electrical current density of 4 into 10 to the power of 9 area per centimeter square, which is more than 1000 times greater than those of metals such as copper. Because of its nanoscale cross section, electrons propagate only along the tube axis. As a result, carbon nanotubes are frequently referred to as one-dimensional conductors. Now heading towards the thermal properties, all nanotubes are expected to be a very good thermal conductors along the tube axis, exhibiting a property known as ballistic conduction, but good insulators laterally to the tube axis. A single-walled carbon nanotube has been shown to have a thermal conductivity along its axis of about 3500 watt per meter Kelvin at room temperature. The value is it's almost 10 times higher than that of copper, a metal well known for its good thermal conductivity, which is 385 watt per meter Kelvin. Now heading towards some of its more properties, carbon nanotubes and graphene are interesting materials because of their unusual properties. The electronic transmission in single-walled carbon nanotubes have a ballistic nature. For example, the mobility of graphene charge carriers is about 20,000. They also have excellent thermal conductivity. The thermal conductivity of graphene ranges from 3000 watt per meter Kelvin to 5000 watt per meter Kelvin. In addition, they have high transmittance in the visible light range. They can be used as a transparent electrodes for optoelectronic. In addition, they have high transmittance in the visible light range. Its good electrical conductivity and large surface area also lead to its important use as a catalyst support. They can be even be used directly for electrocatalysts for chemical reactions. Now over to Mohit.
This is Mohit. I am going to explain the process of polymer carbon conjugated compound nanotubes. The polymer matrix play an important role in combining the excellent characteristics of carbon nanotubes into the polymer matrix. There are different processing methods for carbon nanotube polymer compounds, which includes the solution building, melt blending, and in-situ polymerization, and many more. Let us discuss some of the processings. So let us look into the solution processing. The general procedure involves disappearing NTC in a suitable solvent by vigorous stirring, and then mixing the polymer and the nanotubes in the solution under mechanical stirring. So we need to basically stir the compound. The solvent is then allowed to evaporate under the control conditions, and we mentioned the precautions that we need to take while performing this process. Then we'll move on to next process. Next slide, please. So, melt processing. This process involves heating the polymer above its melting points to form a viscous liquid and introducing CNTs through shear mixing. This method is suitable for treating insoluble polymer that cannot be obtained from solution. This is the process which is most suitable for current manufacturing processes such as injection molding and blow molding and many more. And then thin film deposition technology. The process of polymer nanotube composite material is followed by decomposition or coating on suitable substrate or to produce OSC. So we are just giving a coat on a suitable substrate in this process. Then comes the spin coating process. It involves applying carbon nanotube polymer composite material to rotating substrate. While the composite material is evenly distributed on the surface by a centrifugal force, we need to rotate the substrate until its composite is dry and the final thickness is controlled by the centrifugal frequency. Material composition and characteristics are also to be noted down. And then going to the next slide, we'll have knife coating and slot die coating method. These methods include continuous application of the wet layer along the web without contacting the coating head and paper web. The coating is a result of transportation, the CNT polymer composite suspension to the meniscus between coating head and the coil. The coating of the knife is very similar to scraping, and the laboratory results of show that it can be transferred relatively well to the coating of the roll trollo knife. During the coating process on the squeeze gauge, the paint container in front of the squeeze gauge is used as a source of fresh paint in meniscus. So this is the process of knife coating, and let us look into the next process, injection printing and spray coating. Using this wet film technology, layer can be formed without contact between the substrate and the print head. We need to put drops of CNT compound suspension hydraulic pressure into the space between the nozzle and the substrate. The layer thickness can be controlled by printing several layers or by adding more paste in the space. So this is injection printing. Next, let us look into the nanotube purification. So why we need to purify nanotube? There's an urgent need for alternative energy sources due to the rapid rise in the price of fossil fuels and a great danger of increasing greenhouse gas effects caused by the carbon dioxide emission. We all know that it is a increasing problem. So, sunlight provides by far the largest of the carbon neutral energy sources. Therefore, the current solar or photovoltaic cell based technologies which can be utilized solar energy are of extreme importance. The progress of utilization of carbon nanotubes, graphene, and the nanocomposites is reviewed as highly prospective materials to replace the transparent conductive oxide TCO layers and counter electrode in dye-synthesized solar cells, also sometimes referred as DSC dye-synthesized cells, as a third generation photovoltaic cell. The process of purification was explained in this diagram. So moving on to the next slide, my friend Shantanu will be explaining about the applications of
carbon nanotubes in solar cells. So carbon nanotubes have intrinsic traits which are utilized as electrodes in batteries and capacitors. They have exceptional electrical conductivity and warmth conductivity. Furthermore, carbon nanotubes have also been used as light absorber and photocarrier generation materials in solar cells. Research has also proven that carbon nanotubes have the best reversible capability of any carbon fabric to be used in the lithium-ion batteries that we see in our phones. Carbon nanotubes are also used in DSSC, that is dye-sensitized solar cells. Since there is an urgent need of energy resource due to increasing greenhouse effect which is caused by the CO2 gas. So as compared to the existing photovoltaic technologies, carbon nanotubes are far more efficient in DSSCs. It has also been proven that a strand of DNA may be bonded to a nanotube which could then be inserted into a cell. So carbon nanotubes are used efficiently and effectively in biomedical packages. It holds a lot of applications like cancer treatment, tissue engineering, imaging in that is MRI, magnetic resonance imaging, and also in biosensing. So carbon nanotubes have major role as a whole transport material and also as a flexible transparent electrode that we have already seen. Researchers also handled the aggregate with an electrical pulse in a technique which is known as the spark plasma sintering, which works extremely well alongside nanotubes. From here on, I'll pass on to Karthike, who will tell us about the synthesis and the processes that are involved in the CNT.
Hello everyone, I will be speaking about process of synthesis of carbon nanotubes. So the first method we can use is arc discharge method. So it is a method for the synthesis of carbon nanotubes where a direct current arc voltage is applied across two graphite electrodes immersed in an inert gas such as helium. So between graphite rods some millimeters apart beneath it, excessive current is passed where carbon vaporizes and bureaucracy a warm plasma which give a typical yield of 30 to 90%, where single wall carbon nanotubes are formed with diameter of 0.6 to 1.4 nanometer. So for the next we will be taking the chemical vapor deposition. The chemical vapor deposition method is to cleave a carbon atom containing gas continuously flowing through the catalyst nanoparticle to generate carbon atoms, and they generate carbon nanotubes on the surface of the catalyst or the substrate. So we can say that when it is heated as much as 1000 degrees Celsius in an oven with or without a substrate, carbon bearing fuel line which include methane decomposes on a catalyst into carbon nanotubes, which gives a typical yield of 50 to 100%, where single wall carbon nanotubes are formed like long tube or bundle where are up to 40 micrometer or bundle which have individual diameter of 0.6 to 2 nanometers. Next is laser ablation. In laser ablation, a pulse laser vaporizes a graphite target in high temperature reactor while an inert gas is let into the chamber. Nanotube develops on the cooler surface of the reactor as the vaporized carbon nanotubes. A water cooled surface may be included in the system to collect the nanotubes. So we can say a graphite below several laser pulses evaporates and develops the carbon nanotubes, which give the typical yield of up to 70%, where single wall carbon nanotubes are formed like longer bundle measure 5 to 20 micrometers having individual diameter of 1 to 2 nanometer. Next is flame synthesis. Carbon nanotubes are also made through this system known as diffusion flame synthesis. Heat treatment of a polymer, electrolysis, solar energy are used, and low temperature strong pyrolysis. In flame synthesis, the combustion of part of hydrocarbon fuel line offers the elevated temperature needed, with the residual gasoline appropriate serving as the specified hydrocarbon reagent. Next is electrolysis. This technique is primarily based totally on liquid segment, which changed into invention in 1995 with electrowinning of alkali or alkaline earth metal from the chloride source carbon nanotube deposit on the substrate. By making use of direct current voltage among the electrode in the chamber of molten alkaline earth metal will be produced multi-wall carbon nanotubes. By forming lithium carbonide, synthesis of carbon nanotubes may begin out in liquid segment. Generally, diameter of carbon nanotubes on this technique change into 10 nanometer and duration is 0 by 5 micrometer or greater change into stated and amorphous carbon nanofibers, nanographenes, and encapsulates carbon nanotubes are byproduct of this technique. So next we can go for ball milling. Ball milling is and subsequent annealing is an easy approach for developing carbon nanotubes. Despite the reality that mechanical iteration of the shape can cause completely nanoporous microstructure, it has become now no longer till some years lower back that CNT of carbon and boron nitride have been crafted from those powder with the aid of using a way as thermal annealing. Importantly, the approach entails the position of graphite powder right into a stainless steel box with 4 hardened metal balls. The box is eliminated and argon is introduced. The milling is validated at room temperature for approximately 150 hours long. After the milling method, the power is hardened below an inert fuel gas flow at temperature approximately 1400 degrees Celsius for 6 hours. The mechanism of the approach is unclear. However, it is far believed that ball milling method paperwork nanotube nuclei and the annealing method trigger the growth of the nanotubes. So for the next we have future scope. As you know, because carbon nanotubes are highly electrically conductive, they have ability to be a cost-effective replacement for metal wires. Their semiconductor properties make them candidate to replace existing computer chips. In the future, CNTs will also complete with carbon fiber for high-end uses, particularly in weight-sensitive applications such as Kevlar. Additionally, CNTs have been found to be more environmentally friendly, flame retardant additive to plasmid. Multi-volt carbon nanotube containing paints have also been found to reduce biofouling of ship hulls. discouraging the attachment of algae and barnacles, making it environmental alternative to hazardous biocide containing paints. Also, for next, it is feasible to argue that carbon nanotubes will discover the area of interest in infrared sensing. However, it's mild hard to argue why competing sun cell technology, which includes perovskites, copper, indium, gallium selenides, cadmium telluride, and natural sun cells that have accomplished PCE value of 18 to 25%, need to get replaced with means of carbon nanotubes. Third, the usage of thick and married cal movies within the shape of an aerogel in a bulk heterojunction layout is appealing. These will assist to triumph over the fast excision diffusion duration of single wall carbon nanotubes and the expanded optical density of the absorption tail place left and proper of the principal MOS will increase universal absorption. Next, splendor absorption bands and the tolerable digest assist of single wall carbon nanotubes are high quality to be used as obvious conductive electrodes or hollow delivery layers. Example of those can already be discovered like perovskite, CIGS, CDD, and natural sun cells. Also, an aerosol synthesized single wall carbon nanotube movie as obvious electrode inflated with aid of using Spiro method approach of a PCE of 16% and acid dealt with double walled carbon nanotubes surpassed 17.2% recently, and doped single wall carbon nanotube hollow delivery layers coupled with PMMA or undoped Spiro method have enabled solid 17.4% to 20% PCE. Perovskite, Sunsel, and John et al. Have proven that triphalic acid doped CNTs as obvious electrodes outperform the metallic counterpart in a perovskite sun mobilier with 18.8% and 18.4% PCE done. Next, we come over the result and discussion. Carbon atoms can bond collectively in numerous ways, as in some of allotropic style of carbon and with distinctive body residence. The recognized allotrope consists of graphite, diamond, fluorines, nanotubes, and graphene. The remaining three are mainly artificial. Next, the origin, morphology, and approach of manufacturing have an effect on the result that those carbon allotropes supplied to substance while they are used as an additive, and this differs a lot from shape of carbon to another. Graphene and nanotubes have the pleasant aggregate of resident and benefits incorporation of CNT inside various polymer material and enables the formation of advanced nanocomposite with improved or even novel set of electrical, thermal, mechanical, electrochemical, and electromagnetic properties. Next, so here we can conclude. In conclusion, we can say it is far exceptional that CNT is primarily based totally polymer nanocomposite gift an array of opportunities for his or her use in numerous generation development. However, for mechanical home in particular, a few key demanding situations wants to be addressed and resolved in order that the whole ability of CNTs may be realized. Out of those demanding situations, the cap potential to collect homogeneous dispersion of CNTs and their alignment within side of polymer matrix stay most important bottlenecks. In nutshell, the destiny of CNT is primarily based totally polymer nanocomposite. This is hints at the fulfillment complete within the side the scope of those key demanding situation. Thank you all. Here we end our EL phase 2. Thank you, sir. Thank you.